So in this video, we are going to implement our score and our lives system. Actually, it's not that it's much of a system. It's really just maintaining a couple of static fields that we will be able to set from anywhere inside of our game. So from any script, we'll be able to access these fields.
Okay.
So we'll create a lives field and we'll create a score field. The interesting thing about this video is we are going to make use of the Unity GUI system. It's very powerful. It's very flexible. You're not going to see it in all of its glory because all we really need to do is just put some text up on the screen.
Yeah, just some numbers.
Yeah, show us our life and to show us our score. A little bit later on, we'll take a look at putting a button up and making that button function. But I would like to point out for those of you that are watching these videos that are planning to use Unity for iPhone development, you will want to avoid using the system that I am about to show.
Okay.
Now, why am I showing the system? Well, this is not a video series that is targeted towards iPhone-only development. When you are developing for the iPhone with Unity, or when you're developing for the iPhone, period, there are a lot of things that you need to constantly think about that you don't have to really think about when you're using something like C# and XNA to develop a game for the PC, or Unity for making a game, etc., where we're working on a machine that has a significant amount of power when compared to the iPhone, and a lot more memory and a much stronger graphics processor, etc. So when you're dealing with the iPhone, you're dealing with a little phone. So a lot of things you got to keep in mind. Now, the Unity GUI, the Unity GUI system is very powerful, and you should use it. You should take advantage of it when you are creating games for the Mac, the PC, the web, etc. You just want to avoid this when working with the iPhone. Now, that shouldn't make you go, oh no, then how would I go about creating HUDs and text that has things like score, etc.? There are still things that are built into Unity that you can take advantage of that will allow you to still do GUI texture type stuff, GUI text type stuff. But it's not part of this Unity GUI system, which actually revolves around a very specific function that we're going to be adding into our code in just a second. You've seen the function start. You've seen us override that. You've seen the function update. You've also seen the function, the trigger one that we used, the on trigger enter.
Yep.
Now we've got on GUI. And it's like update where it's going to run every frame, but it can actually run multiple times in a single frame, depending on events that are occurring with the GUI controls and all.
Okay.
Because of that, you really want to look at, avoiding to use that system on the iPhone. You can use it. It will work.
Yeah.
Also, the draw call count can become expensive. And I know that's like draw calls, huh?
Yeah, what's that?
It gets way outside the scope of these videos. And it's something that we will cover later when we start talking specifically about iPhone development using Unity. But for now, just keep in mind what I'm showing you works fantastic, and I encourage you to use it for everything except for the iPhone. All right, so with that, first thing we need to do, let's go ahead and set up a couple of fields in which we can store our data, lives, and score.
Now, where are you going to put these?
Well, again, I'm following along with what Casey had put together, so I'm just going to put these inside of Player. When we come back in another set of videos, another video set, and recreate this game using Objective-C, C#, more along the lines of the way you would use an object-oriented program to write a game. We're going to end up with a game manager, and that game manager is going to instantiate a single instance of a game, and that game is going to be where we're going to have our score and our lives reside.
I gotcha.
As opposed to sitting on the player. We're going to really compartmentalize all of the functionality to very specific classes and keep things as clean as possible.
But that's coming soon to a theater near you.
Exactly. But the nice thing about that system is we will also be using the built-in functionality of Unity. We're going to still inherit from mono behavior for things like our player and our enemy, but we're going to demonstrate how we can marry classes that do not inherit from mono behavior, meaning that they are not attached to game objects. We're going to show you how those can be instantiated and used to control things in a game. Neat stuff. So, all right, so like you said, where are we going to put it? In this example, since I'm trying to do my best to parallel with what Casey did, we're going to come over here to player. We're going to keep it on the player. Now, if you are not a programmer, so you're new to this world, and you've seen me throwing around the word class, and we've talked about objects, and we've been talking about fields or our data members. Just a real quick recap. A class serves as a template for an object. When we take our script, which of course is a class and the way this is all being done, and we drag and drop it on one of our game objects, so we've just taken that script object, if you will, and attached it as a game object, or excuse me, a component to our game object. What we've done is we have created an instance of the class. So you can look at the script, as I'm pointing right here to our projectile script. This is an instance. So think of this as an actual object. So you take the blueprints of something, think of that as the class, you create an instance of that class, and it is as if you've gone in and you've actually constructed what that blueprints showed you how to make.
Okay.
But the nice thing is then you can give it its state and take advantage of its behavior, the whole idea behind object-oriented programming, and we've done just that here. This projectile has a projectile speed of 10, but I could take this projectile script and drag it on another projectile prefab. If I want to create a whole nother one of these guys, or even if I instantiate one of these guys and then come in and set just his speed to something different, he's got a different state than the other guy. So they're each unique at that point. The reason I'm pointing this out is if I was to just do, your regular public float, or in this case, we don't even need to do float. So we're going to do an int, and I did score. And let's start score. We're going to initialize it right out the gate to 0. And if I did a public int lives, and I initialize that right out the door to 3. So we start the game off with 3 lives. What we've just done is we have set these up as instanced variables, okay, or instanced data members of my player class. That means if we were to have multiple players, they would all have their own copies of score and lives.
Right.
In this case, we want to make sure that everybody can access the score and the lives. It's just a single-player game. So what I'm going to do is I'm going to take these guys and make them static. So if I say public static, like such, we only have score and lives in existence once, and they belong to the class player. They're not instantiated with a player, meaning that when I drag the player script onto a game object, we're not going to be able to set the score and the lives on that game object differently than if we were to drag the player script onto another game object. So these guys stand on their own. Does that make sense?
Yeah, they're going to be kind of universal. The same fields will apply to all instances of this class.
That's right, because these don't belong to any instance.
Right.
They belong only to the class itself.
Okay.
So to access score, I would need to say player.score to talk to, and I'm saying player with a capital P. I would need to actually say the type dot score.
Well, you summed it up right there when you said that it doesn't really belong to the instance. It actually belongs to the class itself.
That's right. So that's what I wanted to point out. Using static methods, static fields, very helpful, and that's something that we'll get more into later on.
Okay.
But anyway, so now we only have a score and a life that's in existence once, and with that, next thing we need to do is let's start showing some stuff up on the screen. So with that, we're going to make use of the Unity GUI system that I was talking about at the beginning of this video. So we've got update, and up under update, we're going to create a new function. Again, this is already available to us in mono behavior. We're just going to override it. It's void on GUI, graphical user interface. Again, this guy is going to be called every frame. Depending on how complex your GUI is, it could end up having this function called multiple times in a frame, depending on events. So inside here, what I'm going to do is I am going to simply draw some labels to our screen. And there's a lot of different kinds of GUI controls that we can work with. Things such as the GUI button, the GUI label. We have a text field if we want to type in some text or have a user type in some text. We have a toolbar. There's all sorts of things.
So all the different controls you'd need to create a user interface.
Oh, yeah, there's a lot of good stuff.
Okay.
Now, Lee and I have designed our own GUI system that will work on the iPhone. And perhaps that's something that I can look at teaching people a little bit later on. But it's packaged up in such a way that you feel like you're working with WinForms, which is really nice because you can say button, my button equals a new button, and then you can set its parent and
very nice.
Set its width and height. When we work with GUI controls here, it's all in line, and that's going to make a lot of sense in just a minute.
Yeah.
So let's start out by using our very first GUI control. We're going to use a label. So here's how we do it. We start out with GUI dot. Now we tell it what control that we're looking for. In this case, we're going to do a label. Now, there's two key things that you're going to give to a control. You're always going to give it a rect, and you're always going to give it its content. Okay. And content can be several different things depending on what type of control you're working with. In this case, we're simply going to give a rect that is going to be responsible for positioning him and setting a width and a height. And the content is going to simply be a string. So let's put that together real quick. So the rect, new rect, and again, for those of you that are coming from the JavaScript world, you're not used to seeing the new, just like when working with the vector 3, we're always saying we're making a new vector 3 object. Here we're making a new rect, and you can see that Visual Studio is quite intelligent. It says, hey, this is what you obviously are going to use. And with this rect, we're going to be specifying a left, a top, a width, and a height for this guy. So starting off with our left, this is going to be an X, how many pixels? Say we want to move over 10 pixels. In Y, say we want to move 10 pixels from the top in Y. Now a width, let's say, I don't know, about 60 pixels will work. And a height for this guy, about 20 pixels will work.
And this may be one of those things where you might need to test it if you're using other words.
Yeah. And the interesting thing is, in fact, I'll see if I can work it in here in just a little bit when we start working with the button. All of these guys, when I'm coding, are actually variables are going to be used in here. Fields that we would then put in the class itself that would specify the width of something, etc. And you can, you can get even more sophisticated by using your content and figuring out what the width and the height of the text that you're going to use, and then have those numbers get applied automatically.
Just to help you with formatting.
But, that gets a bit more involved. So we're going to keep things simple. So we're going to say about 60 pixels wide, 20 pixels tall, and we've given it 10 by 10.
Now that calculates from the upper left corner of the screen.
That's right.
Okay.
So now we'll go ahead and comma, and then go ahead and give it our content, which is going to be score, colon, space, and I'm just going to use the old-fashioned concatenation here. So we'll append to the end of this string player. So this is where things get interesting. Player dot score. So instead of just saying score, because we would be looking at ourselves like an instance, we're going to say the player, the class. And as a matter of fact, you can see with the pop-up tip right there, the tooltip, that we have class player. So the player score, because we only have that in place once, and before I terminate that, let's go ahead and close that off, then terminate it. So now we're simply saying, all right, on every frame, we're going to draw a GUI label at this position, and it's going to say score with whatever our score is. So let's go ahead and save this out. We could get even more specific and jump in here and say to string if we want it to be a little more proper here, just to go ahead and have that converted over to a string for us.
Do you have to do that?
It's a good idea too.
Okay.
So let's go ahead and save, jump back over here, and hit play, and you can see we now have score 0.
Yeah.
So that's working. Excellent. Let's now jump back in. And the next one, same thing, is going to be a GUI label, again with a new rect. And this guy, we've now moved down some, so still looking at 10 pixels over so that they are left aligned with one another. But now we're moving down 30 pixels. And again, we'll stick with 60, and we'll stick with 20. And for this, we'll say lives. Put the space in there, and we're going to append to the end of this string. We are going to do player.lives. And we'll go ahead and convert this over to a string, and we'll close that off. So,
but right now, these are just pretty letters and numbers. They don't actually do anything, right?
They don't actually do anything. Yes and no. I mean, we are referencing the real score and lives.
Right.
We're just not manipulating these guys yet.
Right. You've stored a variable and you're showing that on the screen, but that variable isn't being updated in any way.
That's right. Not yet. But as soon as we make this update, we won't have to do anything else on GUI right here.
Right.
On GUI, it's handling it. It's just going to take whatever lives currently is.
Because it's checking every frame to see if it should be changing that.
You got it. So let's save this out and make sure that everything aligns nicely. So come in here and hit play. And there we are with score, and there we are with lives.
Nice.
Good to me.
Yeah.
And yeah, I guess with that, we can go ahead and take a look at getting everything hooked up. Now, the interesting thing is, how long is this video? Oh, wow, we're already at 16 minutes. Yeah, I guess we'll go ahead and cut it here. I was going to look at tying the two videos together. That's okay. So a quick recap. What's handling all of this for us? It's the fact that we've got this on GUI call. If we would have, here's just something interesting to note. If we would have tried taking these and coming up here into our update function, okay, so we're in update, which we know gets called every single frame, and save this out and jump back over here and run this, what you can't see is all the errors we're getting.
Oh, goodness.
You can only call GUI functions from inside on GUI.
Ah.
We can't put those over there. So we need to jump back in here. I just wanted to show that real quick. We've got to have on GUI available, and that is where we put our code. So buttons, labels, everything we would put inside of on GUI. Now check this out. I could have my own custom function, void build UI. And I can take this code and I can paste that down here. And inside of on GUI, I can call build UI.
Okay, that makes sense.
I just want to point that out because when we come back in and we redo this, for those that watch the next step after this video series here with the same game, one of the things we're going to do is we're going to create our own mini WinForms system, so that we're working with screens and we're working with controls, but we're still going to be using the Unity GUI system, but we're going to be doing things like this. We're simply going to offload the actual construction of these objects through the call, these function calls, label, etc. We're going to be pushing those off to somebody else. All that's going to be hidden under the hood.
Sure.
That's what I'm getting at. So we will be able to, even with this simple system, do things like label, score label equals new label, and then give it a label dot bounds, or we could even say label dot x equals this, label dot y equals that, label dot text equals this, and that's all we just put that in one time. But
then later on in like on GUI, you could say like draw score and draw lives.
All of that will be automatic and will handle itself.
Okay.
It's a nifty little system.
Yeah.
But that's something we'll talk about a little bit later. It's very powerful, but it does make working with this stuff real easy. Not to say that the GUI stuff is complex. It's very nice having it all inline, but sometimes you may want to work with it not so inline. Just basically package it all up kind of like an object, pass it around if need be. So we've got this set up. So with that, we're going to bring this video to a close, and in the next video we will you know what? Hang on. You know, I'm just thinking about it, and we could just go in and okay, no, I'm not. We'll get back to it. I so desperately wanted to just add more, but I'm looking at some notes that I've got written down, and I shouldn't be pushing it. So with that, we'll wrap things up right here, and I'll see you guys in the next video.